Today we're going to start graphing our polynomials. It's a good idea to get a general idea of the shape before you start. So if our leading coefficient is positive and we have an even degree, i.e. degree of 2, 4, 6, etc., it will look something like this. We will notice that at the end it goes up, i.e. as x gets really large, y gets really large. Okay. If we have a degree of 2, we'll have at most 2 x-intercepts. You know we could have 0 or 1. A degree of 4, at most 4 x-intercepts. And a degree of 6, again at most 6 intercepts. 1, 2, 3, 4. If I brought it down, there could be a few more. But again, at most 6 intercepts. If our leading coefficient is negative, basically they go the other way. As x gets really large, y gets really large, but negative or really small. It's a weird one to talk about. We can think of it like this. As x approaches infinity, y approaches negative infinity. Okay, so we can see it goes down. Whereas up here, as x approaches infinity, y approaches infinity. Okay, and again, the same rules apply. The degree is the maximum number of x-intercepts we could have. What happens if we have an odd degree? We know what a line looks like. Odd degree of 1 starts down here, ends up here. Degree of 3, again, starts down here, ends up here. So if the leading coefficient is positive, as x approaches infinity, y also approaches infinity, up, up, up. But you know the reverse at the other end for an odd degree. If our leading coefficient is negative, as x approaches infinity, y approaches negative infinity. Okay, and there's a difference between a really large, that's in inverted commas there, negative number, and a really small number. Let's think of it like this. I think it's simpler. Okay, to graph a polynomial, find the x and y-intercepts first. Examine the limiting behaviour, i.e. the ends of the graph, by considering the leading coefficient. That way you can check your general shape is correct. So here we have one that's factorised. You can expect these ones in the advanced course. Okay, so first of all, let's get the x-intercepts. So let's set the polynomial to 0. And solve for x. So x could equal 0, x could equal 2. See, I just jumped into that. I feel confident. X equals 1. So there are x-intercepts. To get the y-intercept, well, let's just sub in x is 0. So we're going to go 0, 2 minus 0, 0 minus 1, and that should give us negative 2. So over here, we grab our ruler, we draw an axis, label it, marking our x-intercepts 0, 1, and 2. Our y-intercept, well, that was silly, that's 0. Our y-intercept is also 0. So now we really need to think about our end behaviour. If I expanded this polynomial, my leading coefficient would be x times negative x times x. So my leading coefficient would be negative 1 because that would be negative x cubed as my leading term. This means at the end it must go down. Now we're just going to make a shape of a cubic. Ew, terrible. Label it y equals the polynomial of x rather than the whole thing, a bit quicker. Okay, let's have a look at another one that is not factorised. So now this is an extension problem. So our first step is, again, find the x-intercepts. Let y equal 0. So I'm going to go x cubed plus 3x squared minus 10x minus 24 equals 0. I now need to solve that polynomial. So we know our steps. Guess a factor, long division, then factorize the remaining quadratic. Pause the video now and you can finish that off. And hopefully your polynomial will factorize to that. So this will mean when I set that to 0, either x can equal minus 2, x could equal 3, x equals minus 4. My y-intercept, fairly easy. If I go back to this polynomial, if I sub in 0, obviously this will be 0, this will be 0, this will be 0, and I'll be just left with the constant term. So my y-intercept occurs when y equals negative 24. Okay, now we're going to do our sketch. So over here with a ruler, we draw our axes. That's important for you, you're getting marked on it. Then we're just going to roughly estimate where negative 2 is, where negative 4 is, where positive 3 is. Feel free to use the scale, you don't have to, it's only a sketch. And we're going to examine the limiting behaviour. I know that's a positive x cubed, so it should go up at the end. I also know the y-intercept is negative 24, so that's somewhere down here. And now I'll make my cubic. A lot of people will try and join that and make negative 24 the bottom, but in fact it's not. We want to go a little bit further, somewhere roughly halfway between minus 2 and 3. It won't be exactly, you'll find out when we do calculus. Create my cubic and label.